Hi, we are trying to couple cases with ANSYS CFX, and the mesh is built by Gambit. This is very important because Gambit has many users, maybe 100,000. So this coupling will be very interesting. We took an SDuct CAD file developed by Friendship Systems, partly because it was handy, but at the same time there is some issue. We'll discuss very soon. First of all, we need to close the both end of the geometry. We are talking about this end, and that end. So by closed surfaces, only because we cannot do CFD on an open CAD file in this case. After making the closed surface or boundary, we have to use the connector. In the connector, basically you just the geometry should be just drag and drop to this connector. Okay, there are 4 windows. If you see our previous videos, you will be able to know what are these 4 windows, and in the middle you have to run, meaning to say it will be looped, and all the geometric proportion can be done on the runner. The next step is to mesh. Please note that in the previous case we saved the file as a state, partly because this can be readable by ANSYS Gambit or Gambit anyway. Gambit is not supported by ANSYS anyway. But there are many users of Gambit. So import the geometry and then do all the things you know. In case if you need on Gambit, let us know. We have been told that we are very expert of Gambit, and do all the meshing. This mesh is not quality, but just for the demo. We have got some layers at the surroundings or at the surface, and we have got some various kind of mesh, and then this mesh has to be exported. So file export mesh. When you save it, there will be a journal files, so we'll be needing this journal file in the cases software. Ultimately, when you exit, it will ask you to save it, and you save it. So then you open CFX pre. In the CFX pre, we need to create a CCL file and pre file. So in this case, we are creating a CCL file. We import the mesh, okay, and then do all these things needed to do the boundary, materials, turbulent model, and various things. And then when you export, we can export as CCL. As you can see, this file will be needed, and also we'll be needing a pre-file. So we start recording. So we from the scratch, we start a new session and do the new session. We start recording. That will be a pre-file. In that case, we read the CCL file, which is just created. First the mesh file, and then the CCL file. So all the boundary and properties will be copied back to the mesh, and that file will be needed. And we ultimately later on we write a definition file, of course. So in the definition file, this is the file we will be using solver. So as we said, that there will be a longer version of this presentation. This is a short version. After we stop the recording, we'll have the PRE file. When you run simulation, we'll be reading the definition file. As you can see, after running definition file, you will have 2 things. One is the out file and .res file, and this is obvious because we are using CFX. Now there are many ways to do post-processing. So in this case, when we do post-processing, we will be needing CSV file. So let's record this session. This is how we record to generate the CSV file, and then we read the result files. We report our results as a tabular form, maybe something called pressure or something. So you can see our mass flow rate, whatever you want. So this is recorded first time in the CSV file. All this we do configure the computation. This run CSV file we have just seen it looks like this, a text file. It should be run in the middle of the cases window, and then this is the runner, by the way. You click and then select this file and this run. It would be running many cases. Once this button is clicked, or this button is clicked, it will run all this command mode written in the run cfx.bat file. You can refresh either of the two buttons can be used to load the results file. So if you click here, you will get results. If you click results, the new pressure and velocity profile will be shown. And by the way, the pressure you can see, which you have set at the beginning, remember. The other thing you could do, if you have parameterized any of these values, either velocity or pressure, either any of the inlet conditions or the size, you can see all the results for the various cases as well. Just to show you an example, the path of the profile has been parameterized. This path you can see in the S dot surface. This value by default is 1.5. If I parameterize this one and then give a minimum and maximum value of 0, 1.5 and 3, for example, so there will be 3 values to calculate and 3 cases to run. And after you as I said, this is your 0 value, lower value, upper value, and 1.5 is the current value or any middle value. So if you run it and solve it, you'll see that in the exhaust seed search you'll find the solutions are there. These are the solutions for different size of that parameter, whatever it is, and you can see the velocity, 3 velocity for the 3 cases, and 3 pressure of the 3 is known, and also the pressure drop, which is calculated and saved there. So this can be very parameterized and optimized as well. We have tons of videos which will be uploading, and if you need more help, just contact admin.don.computing.com. By the way, we linked to many CAD and CFD packages with cases, which makes your life very easier. In fact, you can do 10 man's job using cases. So you should buy cases either from us or by any other distributor or from the headquarters, which is in Germany. Anyway, this is our contact. For anything, just contact us, admin.computing.com. Skype, you can add this one. If you use Google Hangout, please add this one. For any case, anytime you drop an email, we'll get back to you within few hours, hopefully, even in the weekend. Thank you.